Objective: balancing of chemical equations. Balancing of chemical equations is done based on the law of conservation of mass. Law of conservation of mass states that the total mass of reactants should be equal to the total mass of products. Let's take an example of the reaction between zinc and sulfur. If you take 5 zinc and 5 sulfur atoms and allow them to react, equal mass of zinc sulfide is formed as a product. In this equation, an equal number of atoms of each element are present on both the sides, hence it is called a balanced chemical equation. Let's begin how to balance a chemical equation. Reactants, products. Zn plus HCl gives ZnCl2 plus H2. Observe the above equation where the number of chlorine atoms on left and right hand side is not equal. On the left hand side, there is one atom of both hydrogen and chlorine, but on the right hand side, there are 2 atoms each of hydrogen and chlorine. To balance these atoms, take 2 as a coefficient for HCl. Zn plus 2HCl gives ZnCl2 plus H2. Now, on both sides, all the atoms are balanced. Step-by-step method of balancing equation. Example 1. Barium chloride on treatment with aluminium sulfate. The products obtained are barium sulfate and aluminium chloride. Step 1. Write the chemical equation for the above reaction. Step 2. List the number of atoms of the various elements present in the unbalanced equation in the form of a table. In this table, we can see that only barium atoms are in equal numbers on the left and the right hand side. Step 3. In the next step, select a compound which contains the maximum number of atoms from the reaction. Here I am selecting the compound aluminium sulfate, which has 2 atoms of aluminium, 3 atoms of sulfur and 12 atoms of oxygen. From this compound, select the element which has the maximum number of atoms. Here it is, oxygen. To balance the number of oxygen atoms, we can multiply barium sulfate present on the right-hand side by 3. It should be kept in mind that 3 is written as coefficient but not as a subscript. Now the equation becomes BaCl2 plus Al2SO4 thrice gives 3BaSO4 plus AlCl3. Again, compare the number of atoms of the various elements present in the chemical equation. Step 4. As the atoms of both oxygen and sulfur are balanced, we will now balance the atoms of aluminium by using a coefficient of 2 at aluminium chloride on product side. Now the equation becomes BaCl2 plus Al2SO4 thrice gives 3BaSO4 plus 2AlCl3. Observe the table again to compare the number of atoms of the elements on both sides of the equation. We can see that the atoms of aluminium, sulfur and oxygen are balanced. Step 5. Now only the atoms of barium and chlorine are unbalanced. We will first balance the atoms of barium. Place coefficient 3 at BaCl2 in the above equation. It can be observed that the chemical equation is balanced now. Other information. To make a chemical equation more informative, the physical state of the reactants and the products is mentioned along with their chemical formulae by writing in common brackets. Solids are denoted by writing S. Liquids are denoted by writing L. Gases are denoted by writing G. If the solution is made by using water, then it is denoted by writing AQ. Example. CH4G plus O2G gives rise to CO2G plus H2OL. If energy is used in the reaction, then it will be written on the left-hand side. If energy is released in the process, then it is written on the right-hand side. Example: combustion of butane is accompanied by evolution of heat and light energy. Therefore, the equation for the same will be written as